Hello, welcome back. It's time for us to talk about atoms again. Now, in the last class, we talked about the last shell of the electrons and how important that is to know if something's going to react or not. But you may have noticed in the videos that I showed you that they were labeled by different elements, right? We had lithium and sodium and some others that reacted with water and exploded. Now, how do we know that our atoms belong to those elements? That is today's topic. Let's start. Okay, so we talked about the parts of the atom. We have the protons, the neutrons, and the electrons. And now we know where we place the electrons is important. The last energy level, it's what's going to tell us how they'll react. So now let's move on to another part of the electrons, of the atom. So now let's move on to another part of the atom. This is another example of atomic model that you can see where you don't actually have the circles for the protons and neutrons because there might be too many to actually be able to count them. So you'll just have a P for the number of protons and an N for the number of neutrons. So another thing we need to know is what those atoms are of. What do they represent, right? What properties do they have? In order to know that, we look at the protons. The number of protons tell you the identity of the atom. Now, how do we know the identity of the atom? We use the periodic table. So we have all the elements that occur in nature that we have found anywhere in the universe, all documented in one table. That is our periodic table of the elements. So every single atom that has a different number of protons is a different element. And the number of protons tell you which element it is. And then you can find it in the periodic table and know everything about it. Our periodic table is like the catalog of all the different atoms that exist, right? So every substance, every element is made up of one type of atom, okay? If there's different types of atoms, that is not an element, that is something else, and we'll talk about it later. Each type of atom, each atom with a certain amount of protons is a different element, okay? Examples, copper is an element, right? It's in the periodic table, it's represented as Cu, and it's only made of copper atoms. All the atoms of copper all have the same amount of protons. Then we have carbon, for example. Carbon is represented by C in the periodic table over here. That is an element, and it's only made of carbon atoms. Helium is another element, and it's only made of helium atoms, okay? So looking at the elements in the periodic table, you're able to get a lot of information. Number of protons, the number of neutrons, the number of electrons, their energy levels, their valence electrons, how reactive they will be, and a lot of other properties. So periodic table is something we're gonna deep dive into, but today we're just figuring out what atom is it. So in our periodic table, every little box looks like this. You have the element name at the top, for example, hydrogen. Then we have something called the atomic number. Then we have the symbol that represents that element. Usually it's 1, 2, 3 letters maximum. The first one's always capitalized. That is your element symbol. And then below that we have the atomic mass. Okay, so remember when we said that atoms have mass, right? The protons and the neutrons we said was where the mass is found in the atom. So this is the average mass of an atom of hydrogen, 1.0078 atomic mass units. Again, we're still using AMU. The atomic number is what's going to be most important today for us. that is going to tell you the number of protons. So if you remember from our example with counting protons, neutrons, and electrons, hydrogen was the only element that does not have neutrons, right? And it only has one proton, which makes sense if the mass is 1, because the mass of a proton is 1 atomic mass unit, right? So here, this number at the top, right above the chemical symbol, that is going to tell you the number of protons. Every single element in the periodic table has a different number right here, and that's the number of protons. When you change the protons, when you add a proton, that is going to give you a new element. That's how we're able to make new elements, right? We add a proton. It's not an easy thing to do, so we can't just make a bunch of gold, but it's possible. So looking back at these, now we're able to tell what element they are. So this first one tells us that we have 8 protons. So we can go to the periodic table and look for the box with the number 8. And I just happen to know that that is oxygen. So 8 equals oxygen. Now when there's 22, that's a little bit harder. I have to remember the entire song in my head and sing it out loud. 13's aluminum, 14's magnesium. I'm not going to try. Let's just see. 22 is titanium. Okay. So if you look at the periodic table, like I said, they go in order. So you start from hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. You don't have to know all of them. Don't worry. You get a periodic table in your tests. So you just look for the number and you match it to the number of protons. And now you know that that atom is an atom of oxygen for this one. And for this one, it's an atom of titanium. Oxygen is something kind of important because you need it to breathe. And titanium is something we use all the time. We use it in cars and jet engines and surgeries. It's used to, it's one of the materials that we make the tools for surgeries out of because it's very durable. So we're able to tell a lot about that atom just based on the number of protons. And the periodic table is our catalog of all the elements we have ever found. And it's always changing. So the one that you use for your test is not the most updated one. It's the one that the state continues to use, but we have a few more elements after that. And you can always look up the most updated periodic table. I'll have that link in the classroom website so that you can click on the Teams link and it'll take you to the most updated one if you're curious. So let's work backwards. Which of these models would now represent this element? So now, if I give you the element, right? If I give you the box in the periodic table, are you able to tell me what the drawing of the atom should look like? And that should be easy. 1, you should be able to tell with the atomic number, the number of protons, and that should be your first step. If they all have a different number of protons, that makes it easy. So 8 protons, B would be the correct answer here. So again, we're able to tell the identity of the atom based on the protons. The protons are like the name tag for the element. That's what's going to tell you what it is. That's all for today's video. We'll go into more detail in class. Let me know if you have any questions, and I'll see you then. Bye.